This is RD Sharma solution, class 12, chapter 10. Differentiability we are taking. MCQ multiple choice questions. So this is fx 1 minus cos x by x sin x when x is not equal to 0. And when x equal to 0, it is half. At x equal to 0, we have to check for the continuity and differentiability. So those who wants to themselves, for them I have given a reference. So it is subjective. Sometimes people do like this, but I'll give you another way to do it. So if the function is continuous, that means it may be differentiable, non-differentiable, but a function is differentiable, that means it has to be continuous. The reverse is true. Now x equals to 0, we will check for the left hand limit and the right hand limit. In the left hand limit, x is equal to 0, so we will put x as 0 minus h, that is negative h we are going to put. X as 0 plus h, that is h we are going to put. And we'll use this function because there is no two different function for the same. So limit h tends to 0, 1 minus cos x by x sin x. So this is going to be 1 minus cos, in place of x write minus h, divided by x is minus h, sin minus h. Here also the same thing, 1 minus cos h divided by h sin h. Now please remember, cos negative theta is equal to plus cos theta, and for the same sin negative theta, it's going to be negative sin theta. Sin minus theta is minus sin theta. For cos, it is not like that. So in the numerator, it will be 1 minus cos h only. In the denominator, you will get negative sin h. Since we have a negative h already there, so negative gets cancelled and you get h sin h. Now coming on this side, 1 minus cos h by sin h sin h. Now you see the left hand limit and right hand limit are exactly similar. So I will solve one of it and you will know what will be the other RHL if I just solve this LHL. Because both results are same. We have come down to the same result. So what will be the result? You can have a reference on the right. You can say that people have solved in different ways. But 0 cannot be, we cannot have, or we cannot afford to have a 0 in the denominator. That is very true. So we can do it like that, the way people have suggested. So what I will try to here is 1 minus cos h is 2 sin square h by 2. That means 1 minus cos theta is equal to what? It is 2 sin square theta. 1 minus cos 2 theta is 2 sin square theta. So this is 2 sin square h by 2. This is h already there. Now you need h square, so I am putting an h in the denominator, so I have to put have a h in the numerator also. So sin square h by 2 it is. So we need a 4 here also, so we need to have a 4. We cannot just introduce value like that. You have to have a cancellation also. So for now we have sin h also. Okay. Now we know most of the results. This is sin h by 2 by h by 2 whole square. This is sin theta by theta whole square. And we know that sin theta by theta is 1. 2 by 4 will give you half. And this sin h by h by sin h or sin h by h, they are similar. When you apply the limit h tends to 0 for sin theta by theta is equal to 1. So this sin theta by theta is going to be 1. So this is 1. When we apply the limit, this is also 1. Okay. Both ways, both are will follow the same rule. So what is remaining is half. So these are different solutions being provided, and internet you will find number of solutions there. But this is the best solution what I can give you, because both the values are half. When both are half, the left hand limit and right hand limit are similar. They are equal. So when the left hand limit and right hand limit are equal, that means you can say this function is continuous. Continuity we have checked. This function is continuous. Not continuous you can cancel out. This will just check. Not continuous, so this also we can cancel it out. So we have first and third one. Continuous and differentiable, continuous but not differentiable. So we will check the differentiability just now. We have completed the continuity part. So we will, there is a trivial method of putting 0 minus h and 0 plus h like that. What we'll do here is limit 0 x tends to 0 minus, limit x tends to 0 plus. So we'll just try to simplify this question. Fx minus fc divided by x minus c it is. Limit x tends to c. Now c is 0 here. It is x equal to 0 we have to check. So x is not equal to 0, so we have to use 1 minus cos x by x sin x. So fx minus fc, what is fc here? F0 is given as half. This value is already given as half. So you can just put half in place of fc. Now x minus c is what? 0. So you can just have x. So final function will be fx minus half and divided by x. The same thing on the right also, that is the left hand derivative and right hand derivative. So what you can do here is, this is 1 minus cos x by x sin x, that you have to put in place of x, minus half divided by x. Now you can apply the limit, that is 0 minus h, 0 plus h you can use, but you'll see you won't require it. I'll just show you how you can get it done without using that. In the first part when we were checking continuity, I told you 1 minus cos x is 2 sin square x by 2, x sin x was already there, so you can have x square by 4 and 4 in the denominator, x in the numerator, because you have introduced x square by 4. So this sin square x by 4 and x square by 4 will give you 1, and sin x by x will also give you 1, right? So this sin x by x will also give you 1, this 1, and 2 by 4 is half. So 1 by 2 minus half divided by x. Same thing here. There is no change because we are using the same thing. Ultimately you have to replace x by 0, but we will not replace it by 0 because see, 0 is in the numerator. We'll just call it as it is 0 by x or 0. We cannot say it as, if you put 0, this h, remember if you put h, you have to put h as 0, but here we have not used that. The set of points where the function fx is given by this is differentiable, and we'll just check the differentiability, will not go for the continuity because the question is only asking about the differentiability. So the set of points where the function fx is given by this modulus of x minus 3 cos x is differentiable. Now how do we check where we have to, what is the point we have to check? This is for the differentiability of x minus fc by x minus c, limit x tends to c. Modulus of x minus 3 is 0. So x is equal to 3. So we have to check at 3. This is how we get the point. Okay, we have to use the value which is given in the question, not like just like that. So 3 has come just because modulus x minus 3, that is x minus 3 is going to be 0 only when x is equal to 3. Right? So we are going to check at 3. So what is the f3? We'll just see what is the value of fx, but f3 we need to know. f3 is what? Modulus of 3 minus 3 cos 3. Modulus of 3 minus 3, it is going, cos 3 will always be a value between negative 1 and 1. You know, cos and sin always oscillate between negative 1 and 1. This is the highest and lowest value of cos and sin. But modulus 3 minus 3 is 0, modulus of 0 is 0. So you get a 0. So this FC, F3 we are going to put as 0. So this FC can be eliminated. Denominator you have x minus 3. So the simplified function which I made is fx minus this fc is going to be 0 as I just told you. Fx, fc is 0, x minus c, so x minus c is what? 3. So fx divided by x minus 3. Alright. So we'll put x as 3 minus h on the left, we'll put x as 3 plus h on the right. So limit x tends to 3 minus you can write. Here you can write x, limit x tends to 3 plus. Okay. This x minus 3, on the left of 3 you will get negative x minus 3 when you open this modulus. This is a modulus. So when you open this modulus, it's going to be negative on the right. On the right, it is going to be positive x minus 3 because it is modulus. You have to open it anyway. But what value where you are going to get, that can be computed and that can be known at x equals to 3. Because modulus x is x when x is greater than or equal to 0, it is negative x when x is less than 0. Not less than or equal to 0, it is less than 0. So there is a correction, slight correction there. So this is what we are going to put. When we go on the left, we are going to replace the modulus x minus 3 by negative x minus 3. On right, we'll replace it by positive x minus 3. Alright? So this left hand derivative and right hand derivative, and we'll just see whether they are equal or not. If the LHD RHD are not equal, we'll say it is not differentiable. So I'm replacing negative x minus 3, cos x remains like that, we'll replace it by x by 3 minus h in a short while. On the right, it is going to be x plus 3, positive x plus 3, because we have opened the modulus, and this cos, in place of x, we'll put x only, and the denominator you have x minus 3. So you have x as 3 minus h in the left and x as 3 plus h on the right. So 3 minus h is minus, x is 3 minus h minus 3, and this is going to be cos 3 minus h divided by x minus 3, x is 3 minus h minus 3. Here also the same thing, x replace it by 3 plus h plus 3, and this is going to be cos 3 plus h, and denominator you have 3 plus h minus 3. Now this limit and h tends to 0, all you have to write in all the steps, okay? I'm just skipping it just to make it faster. 3 plus h minus 3. So this gets cancelled, 3, 3, you have a negative h. There is already a negative outside, so it's going to be positive h. Cos 3 minus h divided by, you have 3, 3 gets cancelled. You have a negative h here. A negative h is this one, okay? On the right, we have this x minus 3 it is. So there is again a slight change here. And to err is human. That what you can take from this. Okay, h cos 3 plus h divided by 3, 3 gets cancelled. You have a h in the denominator. This gets cancelled. This also gets cancelled. Cos 3 minus h. It is negative cos 3 minus h. Here we have cos 3 plus h. Now if whatever you put inside cos, it is going to be negative 1 or 1 value, right? So you can just have h as 0, cos 3 will have certain value, we don't know, but we don't require it because we have known that it is cos 3 will be some constant value, negative constant, cos 3 and plus cos 3. So they are not equal. That is, this function is not differentiable at x equals to 3. So you have all the real number except 3. That is what you are going to tick, the second option. Let fx equals, so we have 3 intervals here, and we have to check the continuity and differentiability at these points. So is it continuous everywhere, differentiable everywhere, or they are just, this function is only continuous and differentiable at negative 1. So we'll check the continuity and differentiability here, alright, and this we will follow the trivial rule. That is the traditionally what we were doing. We'll just do that. X equals to negative 1. So on the left we go. So when we go on left of minus 1, I'll just show you what we are going to take. When we go to the right of negative 1, I'll just show you what we are going to take. So this is your, see, I'll show you in the number line. We have this negative 1. We have a 1 here. And in between negative 1 and 1, we'll use modulus x. When you go to the left of negative 1, you'll use 1. And when you go on the right of 1, you are going to use 0. So at x equals minus 1, we are going to check. When you go on left, you will take a constant function which is 1. So if you are going to check at x equals minus 1, you have to put x as minus 1 minus h. On the right, you have to check minus 1 plus h. That is what we do normally. We subtract h and we add h on the left hand limit and right hand limit. And when we have this x equals to negative 1, what we get? Only 1, because x is less than or equal to 1, it is 1. It is a constant function. Only one value is there. So all these you have to write, right? X tends to 1 minus, right? On the right you have to write x tends to 1 plus, that you have to write. Limit h tends to 0, that all you have to write, okay? I'm just skipping all these. I don't write it. So you have to just follow this, my instructions, and you have to write it in all the steps. Okay. Now on the right, what we'll get? Minus 1 and greater, you will get a modulus x. So modulus x it is, just put minus 1 plus h. So when we apply the limit x tends to 1 plus, you'll write modulus x. When we apply this limit h tends to 0, you can just put h as 0 and it will be modulus minus 1. This is 0, modulus of minus 1 is going to be always a positive value. Modulus will always give you a positive value. So left hand limit and right hand limit, you see they both are 1. When they both are 1, that is the function is continuous at x equals minus 1. So this is the first thing what we get. Now we will see for the differentiability. If the function is not continuous, we cannot go ahead for the differentiability. So we will check for the differentiability now at x equals 2 minus 1 only. And same point and same results we will discuss. X equals 2 minus 1 LHD, RHD, left hand derivative, right hand derivative. X will be negative 1 minus h, x will be negative 1 plus h, depending upon you are going on the left or the right. So this is when you go on the right, you have to use modulus x. When you go on the left, you have to use a constant value, constant function, that is 1. Okay, the function same is different now, fx minus fc by x minus c. That is what you are going to use for limit x tends to 0. This limit x tends to c in this case. So f minus 1, because fc is basically f minus 1. What is f minus 1? When you put minus 1, what is the equality sign? It is going to be 1. Equality sign is in the first. X is less than or equal to minus 1. So equality sign is with negative 1. Is 1. So f negative 1 is 1. In place of fc, you will just replace it by 1. And this fx on the right of negative 1, we will replace it by modulus x. When you go on to the left of negative 1, in the same way we have done in the continuity, we will replace it by 1. X minus, and this c is negative 1 because we are checking at negative 1. So x minus of minus 1, that is x plus 1. Okay. So the simplified function we will use for LHD and RHD is fx minus 1 divided by x plus 1. So you just have to replace fx first. For that case, you will write limit x tends to 1 minus, negative 1 minus, and limit x tends to negative 1 plus. So 1 minus 1 divided by x plus 1. On the right, you are going to use what? Because fx we have replaced by 1 on the left hand derivative. Right hand derivative, you have to replace it by modulus x. Modulus x minus 1 by x plus 1. Okay, modulus x minus 1 by x plus 1. Now 1 minus 1 is 0. Even if you want to do something, you can just have this minus 1, minus h, all those stuff you can replace. If you want to put this negative 1 minus h and negative 1 plus h on the left and the right, this you can replace. So you have limit h tends to 0, 1 minus 1 divided by x plus 1. X is negative 1, negative h plus 1. This, now it's up to you. See, 1 minus 1 is already 0. And the denominator, whatever we get, just see on the, we'll just show you the right hand derivative also. So if you want to put this h, you can put, but I will advise you not to put this negative 1 minus h or 1 plus h. So in the left hand derivative, right hand derivative, you don't require to have h, as I showed you in one of the question in the earlier discussion. So modulus x will be negative 1 modulus minus 1 x plus 1. I am not replacing it by this minus 1 plus h. So you will get modulus of minus 1 is 1, 1 minus 1 by x plus 1. So you have here, I am not replacing it by h. So it is negative 1, 1 minus 1 by x plus 1. And in the right hand limit also you have 1 minus 1 by x plus 1. So left hand derivative and right hand derivative are equal. You don't have to worry about what is going to come. In some certain questions, you have to worry about, oh, this is going to be infinite or some, indiscriminate value. But you don't have to worry about this because the left hand derivative and right hand derivative are coming same. When they are coming same, it's safe to say it is differentiable at x equals to minus 1. So as I am saying, I showed you negative 1 minus negative h and negative 1 plus negative 1 plus h. You don't have to put that. Okay. In actual solution, don't put that. Just go along with x plus 1 and the way I showed you in one of the question earlier, just a few minutes back. So differentiability at x equals to minus 1 is your answer, because continuity means you can check for differentiability. It can be differentiable, it cannot be differentiable. But once it is differentiable, it will be continuous. So this fx equals to sin x function. So this is the question number 12 of exercise 10.2. We have already discussed this in detail. But there is a question coming which is dealing with the modulus of cos x. So when you have modulus of cos x, you have to understand what will be the modulus of sin x. So when we discussed everything about sin x, modulus of sin x, we knew when it is going to be negative, when it is going to be positive. In MCQ, you just have to check one of the option. So if you want to see how this gets solved, there is a solution which I have already explained. But because you see this graph, and in this graph it is very clear that when you have a sin x, this is a function. Modulus of sin x, that means there will be nothing on the negative y-axis. Because modulus x is modulus of anything will always give you a positive value. So these below crest or trough, whatever you call, this is going to go up. This will be removed. This will be eliminated. So when you check the continuity, you know that there is a way and there is no breakage. If you can draw something without picking your hand from the paper with the pen, this is continuous. So sin x, modulus sin x is already continuous, which you see here. How about the differentiability? Differentiability means there should not be any sharp edge. There should not be any sharp turn. If it is like that, then the function will not be differentiable. But here you see at negative pi, at 0, at pi, at 2 pi, there we have a very sharp turn, sharp edge. And sharp edge simply means non-differentiability. So you have pi, 2 pi, negative 2 pi, you can just call it as n pi. So at n pi, n is basically integer here, because 1, 2, negative 1, negative 2, all these are integers. So when you have n belongs to z or the n pi, this sin x is going to give you a continuity, but no differentiability at x equals to n pi. Okay. Now fx equals to modulus of cos x we are doing. X equals to modulus cos x, the same thing what x equals to modulus cos x, same discussion as modulus of sin x. Now this function is actually showing you cos x. Cos x function is simple, that you can draw just like sin x, but the negative part will not be there. There will be no negative part. Okay, all the part which are in the negative y-axis, that has to be taken up. That is, all lines which are below the x-axis, they have to go up like this. There will be nothing on the negative y-axis, because modulus always give you positive y-axis, the value on the positive y-axis. Now there is no break here. You just see there is no break. Same way we discussed the sin x, there is no break. But these points, they have very sharp edge. When they have continuity means no breaks, but differentiability means there should not be any edge. But here we are at pi by 2, 3 pi by 2, negative pi by 2, negative 3 pi by 2, all have the edges. And since we have sharp edge, that is, you can generalize it taking the integer 2n plus 1 pi by 2. 2n plus 1 is simply the odd number. So 2n plus 1 pi by 2, this shows that all these points are going to give you the sharp edge, and sharp edge means no differentiability. So this function is continuous because there is no break, but this function has, this modulus of cos x has sharp edges at 2n plus 1 pi by 2, so it will not be differentiable at 2n plus 1 pi by 2. Same discussion goes for sin x modulus also, that we have just discussed. Okay. The function fx equals to 1 plus modulus of cos x. Now modulus of cos x we have already known. Cos function we know, y equals x, if it is a line it will pass through origin. When we add plus 1, that means you go up. That is just a 1 point ahead. This is y equals x plus 1. and when we have x minus 1, you are 1 point below. So this is how the function changes. But the actual scene, actual scenario, actual say panorama of the question doesn't change. Similarly, if you know about modulus of cos x, you know the function. Modulus of cos x will always give you positive on above x-axis like the dome shaped structure. So this is a very good drawing by me. Thank you so much. And modulus of cos x will give you what? All these parts will go up. There will be nothing on the negative y-axis. That is the whole idea about the modulus function. So when you add 1 plus modulus x, that is you are just making this modulus cos x go up 1 unit. You just hold this, take it 1 unit up and keep it there. So that is the 1 plus modulus of cos x. Because cos x is going to give you negative 1 and 1 only. All the values will be between negative 1 and 1 always. But when you add 1, that is going to go up. Okay. So this is the line. I'll just show you the line. So this is the line. This is your actual x-axis, y-axis. So this is the imaginary, or not imaginary, but a proper line, which is y equals 1 it is. Y equals 1. And then you add a cos x, so you can just add a cos x function here. So this same function cos x which you see will just be shifted up 1 unit. So whole idea will remain same. Mod cos x will be what? Mod cos x is all the value which is below the x-axis will go up. So we talked about cos x, modulus of cos x. It is continuous everywhere, but it is not differentiable at 2n plus 1 pi by 2. There is all the odd multiple of pi by 2, there is a sharp edge. So it cannot be differentiable. So this is how you are going to give answer, okay? Continuous everywhere is the only answer, because not differentiable at x equal to 0. No, it is differentiable. You see at x equal to 0, it is good. It is very good differentiability it is showing. At x equal to n pi also it is going very good differentiability. Only at 2n plus 1 pi by 2, no differentiability. So these all options, only second option which I see is correct. It is continuous everywhere. Okay. These all are wrong. The second option is correct. So this is how this question is done. Okay. Thank you so much. Take care of yourself.